So, I'd like to start the topic of Pythagoras and trigonometry. Now, as I'm sure you've all heard of Pythagoras. Pythagoras was a man in ancient Greece who looked at a triangle like this and thought, well, why would I go this way? Because surely this length is probably quicker, isn't it? And he was right. If you have your sides A, B, and C, you can use the formula that he developed, a squared plus b squared is equal to c squared, to find out the length of any side of a right angle triangle. Note, this has to be a right angle triangle. So you can start with, let's do an easy one. If I have triangle like that with lengths 4, 3, and c, what can I do? Well, I can use my formula, a squared plus b squared is c squared. So let's write it out. A squared plus b squared is equal to c squared. So your side is going to be A, B, and then C. Your hypotenuse, which is the longest side of the triangle, is always going to be C. So I'll write down this definition. Your hypotenuse is the longest side of a triangle. So let's use our formula. A squared plus b squared is equal to c squared. So let's do 3 squared plus 4 squared is equal to c squared. And then we can simplify that. We do 9 plus 14 is equal to c squared. 25 is equal to c squared. So c is equal to 5. Just like that. This is a pretty famous Pythagorean triple called a 3, 4, 5 triangle. So that is a 3, 4, 5 triangle. Let's do another example. If I have a triangle like this, and I have this length here is 8, and this length there is 12, let's see if I can find the length C. So I'm going to give you an opportunity now to pause the video, and you can work this out for yourself. 3, 2, 1, I'll walk through it with you. So a squared plus b squared is equal to c squared. So if this is b and this is A and B are the sides of the triangle. They can be swapped out. It doesn't matter which side is A. So I'm going to put this side as A and this side as B, and that's going to be C. Okay, so if I did 8 squared plus 12 squared, that's going to be equal to c squared. So we can do it 64 plus 144 is equal to c squared. So c squared is then going to be equal to 208, because 64 add 144 is 208. So we can simplify that. So we can do c is equal to root 208, which is also equal to, when we simplify our surd there, is 4 root 13. It's just like that. Okay. Now, what you can also do is you can rearrange this formula, and you can use that to find other lengths of the triangle. So say I have an example here. Okay, there's my triangle. And I have this length of 12 and this length of 5. What is going to be my length B? So let's put our formula, a squared plus b squared is equal to c squared. Let's rearrange it to find b. So we can say c squared is equal to, well, what's it going to be? Well, how do we get b by itself? We can subtract a squared is equal to, no, sorry, I've done that wrong. We can get c squared minus a squared is equal to b squared. Okay, so let's go and find b squared. So we can say 12 squared minus 5 squared is equal to b squared. And then we can say that 144 minus 25 is equal to b squared. And I'm running out of space here, so I'm just going to bring this up here. So that's going to be 119 is equal to b squared. So b is equal to root 119. And that can't be simplified any further. So that is using the Pythagorean formula. Okay, really important that you remember that. Okay, now what I'm sure you've also heard of when you think about Pythagoras and triangles is how to find angles. So if I have my 3, 4, 5 triangle, that's a right angle, how am I supposed to find that angle? Well, you can use the anagram so, ka, toa. Okay, so this is really simple. I'm sure you've heard of sine, cosine, and tan, right? So you can do the sine of the opposite over the hypotenuse. That's what's opposite, is the angle, the length opposite the angle, and then the hypotenuse. Or you can do the cos of the adjacent over the hypotenuse. So that's the angle adjacent, this length adjacent to the angle and the hypotenuse. Or the tan of the opposite over the adjacent. So you can do the opposite over the adjacent. Okay, so if I'm working out in this example here, how do I find that angle theta? If I've got 3, 4, and 5, and I'm looking to find this angle, what can I do? Well, because I've got all 3 sides of the triangle, I can do any of these that I want. Okay, so I'm going to start off with the first one. I'll do sine. So let's take the sine of the opposite, the length opposite the angle, well, that's 4, over the hypotenuse, which is 5. And if you put that into your calculator, you can do the sine of 4 divided by 5, and that comes out to be 0.03139. 0.0139. Now, you look at that and you think, right, that can't be the angle, can it? So what we do then is we take the inverse sine of that. Okay, so if we do sine minus 1, which you can find on this calculator, if you press the shift button and then you press your sine button, you get sine minus 1 like that. Okay, and then you can put your answer in, and that is equal to 4 over 5, which is the angle we just did. So then you do that again, you do shift sine of your answer, and that comes out to be 53.13. 53.13 degrees. So to 3 significant figures is 53.1 degree. Like that. Okay, let's say I want to do it with a different angle. If I have my triangle like this, it's a little right angle like that. If I have this angle, and I have this length 5, and this length 3, no, sorry, and this length 4, what can I do? I'll give you a second to pause the video and figure it out. Right, let's try. So, if we're looking for this angle theta, how can we find this angle? Well, we only have the length adjacent to the angle and the hypotenuse, so we have to use cos. So if we do the cos of 4/5, well, that is going to be equal to, let's do it, the cos of 4/5, 0.9999. That's 0.9999, ... Okay, so we'll do the inverse cos, and that's going to be equal to 4/5. So if I do the inverse cos, that's 4/5, or 0.8. And then do the inverse cos again, I get 36.869 equals 36.869 degree. And to three significant figures, that's 36.9 degrees. Nice and easy. So, if I have a question that's asking me to find a length when I'm given an angle and a length. So let's try this. If I've got a triangle here, and this length there, angle there, is 30 degrees, and this length here is 6, how can I find this length A? You can use your SOHCAHTOA again. So you're looking to find the opposite, so you know it's going to be either tan or sine. But you've also been given the hypotenuse, so you know you're going to have to be using sine. So you can say the sine of the angle 30 is equal to the opposite over the hypotenuse. So that's going to be A over 6. So we can then find A, so we can times both sides by 6 to get rid of the denominator here. So 6 sine 30 is equal to A, and then in your calculator you can do, do 6 sine 30, and that's equal to 3. So A is equal to 3, like that. Let's try another one. This is going to be the last example. If I have a triangle and I have a length 45, an angle 45, sorry, and I have this length of 5, how can I find this length B? Pause the video now and figure it out. So, to find length B, well, what have we got? We've got the length opposite the angle, so we know it's going to be sine or tan again, but we're trying to find the adjacent to the angle, so we're going to know we're going to be using tan. So if we plug that in, tan of 45 is equal to, well, it's the opposite over the adjacent, right? So we'll say 5 over A. We can rearrange this, so we can say that 5 is equal to tan 45. Sorry, pardon me, I've lost my train of thought there. You can say that A is equal to 5 over tan 45. So we plug that into your calculator. You can say 5 over the tan of 45. And your answer is 5. So, sorry, B, that's length B. B is equal to 5.